Great. Hey, thank you very much. As I think previously mentioned, my name is Ray Hagan. I'm the Global Product Line Manager for Prolabs. And the topic of today's presentation is going to be PON and 400 gig. So I'm going to, without further ado, I'm just going to jump right in because I do have a lot of material to cover today, and I want to have time for questions. So I want to just not waste any of your time and just keep on moving along. So for our agenda today, we'll be talking about next generation PON and what that means. We'll talk about the challenges and architectures, Prolabs PON transceivers and roadmap. And also talk about the line side of PON, which is experiencing some big changes here with the next gen PON. We also briefly cover some of our passive PON products. As we move on to 400 gig architectures, we're going to spend a bit of time about what the impact on the network 400 gig is. And that's going to be primarily in that aggregation and breakout portion of the network. Then again, cover Prolabs 400 gig transceivers and roadmap. All right, without further ado, let's just get moving along here into our PON deployment and challenges. So some of our observations with working with customers around the world is that next-gen PON services are going to challenge the scalability of existing PON architectures. So it's going to be pushing the core and aggregation network upgrades, even up to 100 and even 400 gigabytes because of the sheer amount of data that next-gen PON services can provide. And a little more practical concerns, performance over temperature is going to become part of our customers' logo or lingo, if you will, when it comes to the line side optics. So outside the friendly confines of a central office or head end or wire center, these transceivers must perform beyond commercial temp standards. And another important point is that GPON and next-gen PON coexistence methodologies have not, they've not really reached critical mass. I mean, they are not yet widely deployed. Like combo PON, for example, is a promising technology to reduce both CapEx and space, but its implementation remains limited. So right now, it's kind of a build your own adventure approach. It's not really helpful in growing standard solutions for this what we call coexistence in the next-gen PON arena. And if that was not complicated enough, 25 gig, 50 gig PON, 100 gig PON, even coherent PON options are projected in the future. So that does tend to muddy the waters a bit when it comes to PON architecture. So when we talk about the architecture of a coexistence, so that basically means that GPON and XGS-PON and other technologies can ride on the same fiber out to the customer premises. So if we look at the top end here of this schematic, we have a GPON transceiver and a PON OLT, an XGS-PON OLT transceiver. And in case of a passive coexistence element, which essentially is a WDM coupler, it will combine those signals under a single fiber out to the outside fibers that are connecting each individual premises through a splitter, and all the traffic is being passed to each individual customer premise. It could be a single family, it could be a multi-dwelling, or it could even be a mobile tower. And each one of those locations will have an ONT, and that ONT will then read just the wavelengths that are applicable to them. So if it's a GPON wavelength, so a 1490, 1310 type, it will only see that light. Likewise, an XGS-PON will be 1577, 1270, etc. So that's how coexistence works. It's not a forklift upgrade from the old GPON network to XGS-PON. It is simply an overlay of a new network on top of the existing GPON network. And there's a new concept called combo PON on the market, and that combines both GPON and XGS-PON onto a single transceiver. So therefore, it essentially uses your OLT port a little more efficiently, and it reduces any loss that might come with a coexistence or passive element. But other than that, it works exactly the same way, where it can pass on traffic between various flavors of PON out to the customer premises. So another big part of the PON network we're seeing with these PON changes with the PON network is in the aggregation and transport. So in past generations of PON, specifically GPON, you have remote OLTs in the field. So these are the boxes out in the field that then can provide PON services. They would need to connect those back to their transport via transport network back to a core network. And oftentimes they'd use 10 gig Ethernet, maybe a CWDM, DWDM, or maybe a regular ZR or ER or some more common optic than what we've been used to. Well, with all the different increases in bandwidth with next generation PON, all the new remote OLTs, or I should say many of them, now have 100 gig uplinks, meaning they have a QSFP28 port built into those OLTs that now can connect to a transport network or actually all the way back to the core of the network. So that does introduce some new issues in terms of 100 gig optics, because QSFP28 optics were designed for the data center. The data center, is in a nice, friendly, climate-controlled environment, not in a cabinet that might be on a pole in the field or somewhere where the sun's beating down on it, or perhaps somewhere where it's very cold. So outside of the friendly confines of a wire center or head end or central office. So we get into the applications and kind of seeing an overlay on top of these of this network, if you will. You can see the Prolabs transceivers as we've overlaid them, where you have a GPON OLT, where you have B+, C+, C++, C-temp, I-temp, all kinds of different flavors here, right? Along with the XGS PON OLT. So OLT, just for a bit of a primer on the technology, the OLT is the point in a PON network, and the multi-point is the ONT, which is the customer premise device. Now, in this instance, when you have a transceiver that plugs into an ONT, that transceiver is called an ONU transceiver. So again, a lot of alphabet soup, a lot of things that can get a little complex when you're dealing with large deployments, especially, and when you're used to simple transceivers that were SR, LR, ER, ZR. This doesn't quite fit that mold, if you will. But that's one of the key things with PON. It's a point to multi-point. You have an OLT on one end and you have multiple ONTs on the other. So in this instance, most GPON ONUs or ONTs have fixed optics on board. That they've been deployed this way for many years. However, as we migrate more to this XGS PON world, we now have 10 gigs downstream, and this 10 gig may be used more for commercial business services and residential. Many of the CPE devices being deployed nowadays have an SFP or SFP plus slot that can be used for a transceiver at the customer prem. So it does open up a new world for us, as a transceiver supplier, in terms of where we can fit our transceivers in the network. You can also see down here at the bottom, the combo PON OLT talks a little bit more about it. And I've overlaid here the equipment we have in our lab that supports these transceivers to give you an idea of the testing we do in our lab to make sure we have full compatibility and interoperability with these network equipment manufacturers. Now, I do want to point out here there is a GPON ONU with MAC. So what does that mean? So that means it has an actual MAC chip or MAC address on that SFP. Now, when a customer is providing, a service provider is providing business services over a PON network, and they're providing it commercial business, they may have a customer premise switch that they prefer because it has tie-ins to their management systems, their network systems, their billing systems, things like that. And a historical PON ONT they may get from their network equipment manufacturer does not have those ties. So therefore, a MAC, often called an ONT on a stick, can be used. You can go into the uplink or line side of a CPE switch, and that transceiver itself will look just like an ONT to that OLT on the other side that allows the service provider to integrate that CPE hardware into their PON network and not lose any of the management characteristics that they need to provide services to their customers. So if they're providing quality of service, things like that, they want to use that existing CPE devices. So that's another type of transceiver that's used in a PON network. So as we move into some of our service provider applications, again, and we look at the line side, if you will, you've got this aggregation and transport where you're aggregating multiple PON OLTs back to your core. And here you may have 100 gig transceivers, you may have 10 gig transceivers. The key thing there in that spot there where you're going to remote OLTs is the ability to provide industrial temperature. So neg 40 to plus 85 is the industrial temperature envelope, whereas C temp or commercial temp is a 0 to plus 70 C window. So what we're seeing in the market specifically is that high temps appear to be really the problem when it comes to remote type of environments, because they may be in areas where it can be very hot. And if you push that operating temperature beyond plus 70 C, you could definitely see some interruptions in service. We're not seeing it at the cooler temperatures so very often, because that equipment in the field often helps heat the transceiver. However, if you do have an environment or a possibility where you lose service for whatever reason, and it's a very cold temperature, it's below that 0 degrees Celsius, and the system boots up, you do run the risk of the transceiver not booting up if it's along with the switch or the host if it's below that 0 C if you run commercial temp in the remotes. So just a little bit of a little commentary there on the importance of using iTemp in that remote type environment. Now in the core, we're seeing a lot of 200 gig, 400 gig, other sorts of products there. We'll get into those a little bit later in the presentation. So in terms of the PON portfolio and roadmap, so as far as Prolabs is concerned, we have a very full portfolio of PON transceivers. So starting out with GPON, in our OLT transceivers, we have the B+, C+, and C++. So yes, that is a mouthful, and there are 3 different transceiver variants in that grouping. And really what that means is your laser power and your optical budget that you're providing to the network. So the B+, PON itself has a by standard is really by quote unquote, I'm using my little fingers, little quote unquote standard 20 kilometer technology. However, you've got different variables that fit into this. What's your split ratio? Are they using 32-way splits, 64-way splits? That's what GPON. And how long is the loop from beginning to end? And therefore, when service providers are building out their PON, they need to know, they then will have what optical budget they're going to need to reach from beginning to end of that PON, and then they can choose the OLT transceiver they need if it's a B+, C+, or C++. That's still a mouthful. Sorry. Then we do have different variants in operating temperatures, so commercial temperature or eye temperature, as mentioned. And these are going to have an UPC-SC type of connector that come off the front, and not opposed to an LC, which you can see with typical transceivers. And OLT transceivers are, I hate to ever say always, but generally, and if not always, going to have a UPC-SC. And you're going to need a UPC to APC patch cable there typically to connect to the fiber plant that then is feeding the PON network. The historical PON networks, when they first began being built, sometime in the early 2000s, all use APC-SC connectors due to 1550 RF video being overlaid on top, and they want to cut down on back reflectance, so just a little high performance deal. So therefore, that part of the network is legacy for many customers, and just it was the go forward connector architecture. So that particular piece of the network will require a patch cable from UPC to SC. And the GPONs are going to be SFP form factor. Now, as we move from left to right here, see we actually have the ONU transceivers. Now that ONU transceiver is going to be the same regardless of what the GPON OLT is going to be just by standard. That's the way it is. We do also offer an APC-SC option there. Then we also do offer some of the legacy EPON. Now there is not very many manufacturers offering EPON today, and very few service providers even offering EPON in the network today. They've generally replaced that, but it's something we can supply if needed, because some customers very well may need it. Now, XGS-PON is the new technology that's being deployed today, and that is essentially 10 gigabits, and that's a symmetrical technology. So 10 gigabits downstream, 10 gigabits upstream. And it runs at different wavelengths. It runs at 1577 down and 1270 upstream. Whereas the GPON technology in EPON is 1490 downstream and 1310 upstream. So these can coexist on the same fiber as I mentioned earlier. And we're actually seeing this technology finally hit, if you will. It's taken a few years. This has probably been around since 2016, 2017, but we're finally seeing it kind of reach that critical mass point, if you will, where customers are finally, and service providers are starting to deploy this technology. And primarily they're looking at for business services, so they can leverage the PON network for business services. So something to keep an eye on. Right now, Adtran, Nokia are the real key leaders with this technology, and I suppose Huawei as well. And they're leading the way with XGS-PON out there in the field. But that's what we're seeing right now in the market. And also a 10 gig EPON. And we're seeing this with cable TV operators, so MSOs, specifically in North America, where they're using it because it couples up very nicely with their DOCSIS network. But we're seeing it being deployed in the market. So with that, I'm going to kind of pause here for a quick, if there's any questions about the PON transceivers we've talked about so far, or PON in general.
Okay, Ray, it seems there's no questions at this point.
Okay, thank you. And now we'll get into some of the fun stuff, right? So what OEM compatibility or network or NEM compatibility can Prolabs provide? Everything marked here with an X or with a check mark is a platform we can support today. NA means that network equipment manufacturer does not offer. So we're doing pretty well overall with what's out there in the market. We're often looking to do, as other manufacturers come on board, we're happy to supply those as needed.
We have a question, Ray.
Yes.
Arista, do you support Arista?
Arista does not offer a PON transceiver, or they don't support PON in their network or in their architecture. We often are running into them. They may be used in that aggregation type, where perhaps they're bringing back the uplink from OLT back to their core network, and we're seeing Arista in that context. But we don't. Arista isn't a PON platform per se. Is there another question?
Just sharing comments.
Yeah. Kind of stuff that you're using.
I'm sorry, I didn't catch that.
No, it's okay. They explain it to each other.
Yeah, it was a commentary amongst, yeah.
Don't worry about it, Ray.
But that's great. So that's cool. Thank you, Ray. We can go on.
All right, good. Yeah, so the background is just a little faint there. That's why I was asking. So, okay, great. Thank you.
No problem. I think you couldn't hear us, yes. But you can
All right.
go ahead, Ray. Thanks.
All right. So, and next part, we're talking about combo PON. So, as I mentioned earlier, combo PON is there to really utilize that port capacity. So, anytime you get, customers are concerned about the switches, right? And how do I maximize my port utilization? And combo PON allows them to run two different services, two different networks, if you will, out of the same port in the network element. So it's pretty exciting for service providers. It offers them, a way to really maximize that port utilization. So there's a few different flavors for combo PON. There's an EPON that has both a 1 gig EPON and 10 gig EPON. Then there's a XGS PON / GPON, and this does two different variants of optical budget, N1B plus and N2C plus today. So you can see there they have two different sets of lasers built into the optic, or two different sets of optics built into the transceiver, 1577/1270 and 1490/1310. So that's a very, I think customers get really excited when they learn about these optics and see how they can apply to their network. The real sort of I want to call it a rub, but the thing about this is not every platform supports a combo PON. That platform has to know what to do with that optic when it's inserted. That's the key thing with this is it's not a magic transceiver that does all. That platform has to support a combo PON transceiver. So that's a key thing there just to keep in mind when working with customers. We work with customers on that. We do support these with OLTs and ONTs in our lab from Adtran and Nokia, so we're excited about that. When it comes to combo PON, our compatibility, Adtran, we have the TA5000 XDX in-house. We've also, successfully tested these in the field in the San Zone platform, Huawei. And the Nokia is using a different form factor. And we're looking at, we'll have this on our roadmap when we'll be able to support that form factor. And Radisys is right around the corner also. Again, these are the platforms that support combo PON today. So look at our roadmap. And obviously, I've got the year wrong at the top. We'll fix that. But in terms of calendar year 22, quarter 4, this quarter we're working at bringing the next XGS PON variant, so another optical budget, so it can provide additional optical power for the PON, the E1 transceiver type. And next year, the Nokia SFPDD combo, along with another combo PON that combines the E1 XGS PON and the C++ GPON. So in all fairness, I did not name the PON transceiver nomenclature. Someone else did. I did not. It's a mouthful to say every time and trying to keep everything straight. My sales colleagues on the line here, they definitely, I feel for them because they got a lot to worry about. Then we throw in all this PON nomenclature and it gets a little confusing. So anyway, I'd like to just put that disclaimer out there on that not my fault. I didn't do it. So anyway, sorry, I digress. And then also next year, we're going to see 25 gig and 50 gig PON transceivers on the market. However, I really don't think we're going to see 25 gig or 50 gig PON, platforms that can provide those services until the next year, probably 2024. So as usual, transceivers kind of lead the network equipment platforms by a good chunk, usually half a year. But here we are already talking about the next generation beyond the current next generation that we're already talking about. So, all right, once again, I digress. As I mentioned, the OLT and line side optics, and it's pointed out now with those remote type of environments that PON often is deployed into. For the first time, we really got to think about 100 gig transceivers outside that data center or central office or wire center environment into where they are not going to be, where the environment may not be friendly, and therefore, we have made a concerted effort to produce and offer 100 gig iTemp transceivers. Now we can provide from 10 kilometer up to 40 kilometer today in iTemp, and next year our roadmap has an iTemp 80 kilometer ZR4 transceiver that we're excited about. We can't wait to have it, but that is a exciting development for us in this iTemp type of environment for 100 gig transceivers. Now, when we get to this sort of bandwidth environment, and not every service provider or carrier is going to have type of fiber environment to support multiple 100 gig backhaul connections, if you will, whatever you want to call it, out to the field. So there are also 100 gig WDM technologies that can work passively muxed to reach up to 40 kilometers, or it can be used in EDFA, or even a BiDi, which is a single fiber 100 gig optic. So now we have a wide variety of these sorts of optics as well. So oftentimes customers are looking for what I like to call drop-in upgrades. Perhaps they have a 10 gig, 40 kilometer setup where they have DWDM optics on each end, CWDM optics on each end, and they want to upgrade that whole link to 100 gigs across the way. Well, because of the dispersion and other issues, it's not quite as simple when you get beyond 10 gig. So we do have a wide variety here of items. We do have QSFP28 LR1 CWDM4, so it allows us to go 4 100 gig single lambda transceivers up to 10 kilometers, passively multiplexed, as well as we have our O-band WDM, which allows us to do 8 passively multiplexed 100 gig connections up to 40 kilometers. So those are our two sort of passive mux type items that kind of get us into that drop-in upgrade type environment. We also have BiDis. So we have a LR1 BiDi. So what this is it's a single fiber BiDi, so similar to what you may be selling to a customer today, but it has 10 kilometer reach and 100 gigs. So 100 gigs in each direction on a single fiber. That's a very new, exciting product for us that our customers are very excited. We're going to have a 40 kilometer option for this in the near future. We do have a number of PAM4 DWDM options that require an EDFA or an EDFA that we can offer also to customers who maybe need that 80 kilometer reach for a full DWDM. So this is just a kind of an FYI of some of the other options that are available in that market for some of these types of environments. And we do have some connectivity products that I'm going to briefly go over. I want to make sure we have time here to jump into 400 gig. Our passive connectivity, we do have a sister company that can offer central office or fiber hut type patch panels and high density type of fiber frames. We also offer FTX splitters, the coexistence elements we mentioned. And also we have a full line through our sister company of multi-dwelling unit wall boxes, cabling, that sort of thing. And here's some of the other things we offer under the Prolabs banner: our LGX splitters, couplers, our coexistence elements, pigtailed splitters, and some rugged outdoor patch cables. Pretty standard fare for PON connectivity. A little bit about the architecture beyond the transceivers. You get to passive connectivity. This is what PON network is going to look a bit more in the outside plant, about optical splitters, distribution cables, fiber termination boxes, things like that nature. And we've got, with our sister company, we've got solutions for nearly every step here in the network. Especially on the CPE side, this is one area where I think our sister company has a very great value prop to customers, where they have these fiber patch preterm cassettes, outside plant boxes, these wall mount products that have a reel inside that allow really reduced installation time and to really simplify installation, reduce the costs of deploying, especially in a multi-dwelling unit. Okay, well, that's out for the PON part of this presentation. I want to open it up for questions on PON, if there's any questions about PON at the moment. If I went too fast, you need me to go back and review anything, please let me know.
Thanks, Ray.
Okay, thank you. So we move on to 400 gig. So when we think of 400 gig today, largely it is an upgrade from the 100 gig infrastructure. That's essentially what many of our customers are looking at 400 gig today. It's really an upgrade from existing infrastructure. So this would be a typical data center type environment. We have servers, top of rack switches, your inter row, your spine, your routers, and eventually your data center interconnect. So in that top of rack type thing, you're going to have a switch at the top of the rack, and you're going to have, say, a DAC or direct attached cable or active optical cable or SR4 transceiver that will connect down to 100 gig servers, or I'm sorry, to 25 gig servers in your rack environment. So this is a typical 100 gig infrastructure. Likewise, we move out to the 20 meter from the end of row type, from the top of rack. You have the same thing. You're going to have AOCs or SR 100 gig SR4s. And we move to 500 meters. You're going to have your breakout type transceivers or your CWDM4. We'll just keep on moving on here with the progression of where transceivers are in a 100 gig infrastructure. So this is what we have to work with today in that data center architecture. You have some pre-links that are already there in terms of reaches, things like that. So now we look at a 400 gig infrastructure. How does that overlay on top of this? Really, that's the question that we help customers solve every day. So when it comes to that architecture, there's some changes. So there's DACs, AOCs. You have an 8x50 or 4x100 type of environment rather than a 4x25. You have a DR4, which is a 500 meter type of transceiver. We'll get into some of these things in a little bit. But you move up and you have some different changes there in terms of the transceiver types offered. So essentially, though, with the way the 400 gig transceivers are architected in the network, you can leverage the existing infrastructure, which may be 100 gig today, and you can provide 4 times the bandwidth upgrades using that same infrastructure. And there are some 100 gig options that do fit into this that are very important to the 400 gig and with some of the challenges, and we will get into these a little bit in terms of the 100 gig single lambda. But again, that's a very important part of this, part of that 400 gig infrastructure. So, and also in a service provider environment, definitely not immune. So the data centers were the first upgrade. Now we're working with service providers every day we're answering these same questions. I have this core infrastructure. I need to upgrade to 400 gig. How am I going to do it? I need to run that out to the leaf environment, to my edge. How am I going to do it? Eventually, it's going to go beyond the edge to the access. So that's really where that service providers also fall into that 400 gig upgrade. So you can see, even if it's a data center or a service provider, it is that aggregation and breakout consideration, which is the big things we're working with customers on. And across the physical layer, so across both transceivers and cabling, it really requires a lot of thoughtful planning when deploying a 400 gig upgrade. And the first thing we like to talk about is interoperability. So deployed 100 gig transceivers, for example, CWDM4 or LR4, these are not interoperable with a PAM4 400 gig interface, meaning if you want to aggregate 100 gig connections up into a 400 gig port, you cannot use existing 100 gig transceivers, i.e. a CWDM4 or LR4, into that port. The modulation will not match up. It's just not possible. So that's a pretty important point when you're dealing with this. And here's why. For example, this is a 100 gig CWDM4. Inside that transceiver, you have 4 transmit and 4 receive wavelengths that go through a mux, if you will, and they go on to the other side up to 2 kilometers. And inside that transceiver, you have those 425 gig wavelengths. They're converted from optical to electrical. They're presented to the switch as a 4x25 gig electrical interface. So that's how a 100 gig CWDM4 works. Now, the CWDM4 is a 2 kilometer optic. Now as we move to this 400 gig world, it requires a PAM4 modulated single lambda transceiver for that 100 gig option. Now that the next equivalent there is going to be a 2 kilometer FR1 transceiver. Now this transceiver does not have the 4 wavelengths, right? It has a single lambda or one wavelength, or one lambda, if you will, that goes on transmit and receive. And inside that transceiver, there's a DSP and a gearbox that then retimes it and presents it to the switch as a 4x25 gig electrical, just like the CWDM4 does. But because that has 1 lambda, it's PAM4 modulated, it could not link up with the CWDM4 transceiver. They just are not interoperable with one another. That's an important point we like to get across to all customers, regardless if if it's something you work with every day or not. It's always good for a good refresher just to make sure everyone's on the same page with the difference between a single lambda transceiver and a PAM4 transceiver and a NRZ 4-lane transceiver. Another thing, next consideration is when you're dealing with these sorts of aggregation or breakouts is the fan-out cables or MPO cassettes, meaning that you have to make fiber cable infrastructure decisions. So decisions are ahead always when you're looking at these sorts of things. So look at these cabling considerations. So if go back to the initial slides here on 400 gig, so converting that 100 gig 4x25 gig architecture up to a 4x100 gig, we want to do everything very familiar, where you're leveraging the same MPO cable architecture if you can. And we're looking at the 400 gig breakout cabling considerations. So there's a multi-mode fiber transceiver, 400 gig, so it's called SR4.2. It can break out to 4 SR1.2s using that same MPO 12 multi-mode fiber infrastructure as your 100 gig network. So it's very important. That's a new transceiver on both ends for the 400 gig and 100 gig. And I think the important thing to note here is, if you don't have an MPO 12 multi-mode infrastructure today, and you're looking to upgrade, it might just be best to go to single mode fiber, because as we look ahead to 800 gig, there's not a multi-mode fiber, a legitimate multi-mode fiber option cooking, if you will, today on for 800 gig. So any upgrades may need to be on single mode fiber to make sure that you don't have any wasted 800 gig may be a long ways away, but just to keep in mind that you don't want to waste any sort of fiber cabling investment today for the future. So just something to keep in mind there. Now we get to the single mode breakouts or parallel series modules, if you will. There's the DR4, which is a 500 meters. So this has a MPO connector, and it is demonstrated there at the bottom. It will break out to 4 what we like to call DR1 QSFP28 transceivers. And those are all PAM4 single lambda. So they go back to that DR4 transceiver on that, just as the diagram there's at the bottom of the screen. Then there's the DR4 Plus, which some people may call it a DR4 Plus, DR4 Plus or 4x FR transceiver. Again, I didn't make up the nomenclature, but it just is what it is. And that's a 2 kilometer, and it connects to a QSFP28 FR1, which is a single lambda 2 kilometer optic. And again, I didn't come up with the nomenclature here, but this is just what was used in the market. What's used in the market. And it's important to understand some of the different terminologies here set to make the right decisions. There's also a 10 kilometer option for this breakout, which is what we're calling the PLR4, a parallel LR, 4 lanes. Some people in the market are calling this a DR4 plus plus. So again, and that the 100 gig option on that is a QSFP28 LR1, and that's a 10 kilometer optic. So this is how that 4x breakout / aggregation network is aligned here in the 400 gig network. A lot of things to keep in mind, a lot of decisions as you move down that route. So the first option is, how do I connect those, right? How do I physically connect that 400 gig transceiver to those 4 100 gig transceivers? So first option is a fan-out cable. So literally a direct connect, right? You connect the MPO into the 400 gig connector, and it goes to 4 duplex LCs that go to the QSFP28s. Pretty standard. It's intuitive patching. It's just a plug and play. Does not use any rack space. I think the real issue here is there's complexities when you deal with the length of the cable assembly and the breakout lengths, and is it going to be just in a top of rack type environment, or we need to connecting from end to row to these individual 100 gig transceivers. So there's different things, and that this sort of environment not always the easiest for that. Some of the cons, that's those complexities. You do reduce some flexibility in port management and cable management. The other option is a breakout cassette. So this is a standard, structured cabling breakout cassette, which you can have, 3 MPOs. So you can connect 3 transceivers, breakout transceivers to the rear. You have 24 LCs on the front, and you have a lot of flexibility there to patch amongst your network. Some of the cons, you're bringing up MPO connector polarity, which can be complex if you don't deal with it every day, and does occupy rack space. So those are some of the decisions that you have to make when you're looking at this aggregation type environment. Okay, I'm going to jump into our portfolio and roadmap on 400 gig right now. Does anyone have any questions on the material we've just gone through?
Okay, thanks.
Okay. All right, well, I want to start from the top here on what we offer. We offer 400 gig DAC and AOC cabling. So if you're familiar with network cabling for DACs and AOCs, pretty simple. DACs are copper cables. AOCs are optical cables with transceivers on each end. So we offer QSFP DD form factor, OSFP form factor. So yes, there are two different form factors for 400 gig, both QSFP DD and OSFP. We offer DACs and AOCs for both. We offer breakouts. So for example, we saw the last discussion about how you want to do aggregation. Well, yes, we have another option for you, another decision for you using a AOC, which is a copper type environment where you have a QSFP DD on one end and QSFPs on the other for 4 by QSFPs or 2 by 200 gig or even 8 by 50 gig. So we have a number of options there. And we also offer the AOCs that do have a 4 by QSFP option there. So a 4 by 100 gig QSFP AOC. So we offer a full line of these, and very much not quite as popular, I think, as we had anticipated probably a few years ago, as they are in 100 gig. We're seeing more customers use transceivers in 400 gig right now than DACs and AOCs, and could be due to could be availability, generally availability in the market. It's hard to say right now exactly why DACs and AOCs are not quite as popular at the 400 gig levels they were at 100 gig. So we move on to our transceivers. So we offer a number of transceivers for different uses. So you can see our multi-mode transceivers. So the SR4.2, which I mentioned, which does use that legacy MPO12 connector as a 100 gig SR4 would. There's also an SR8, which is probably more common in the market. This was the first multi-mode 400 gig transceiver. That uses an MPO16 cable, which is kind of an oddball connector out there, but that's what it uses. So it's actually 8 lanes of 50 optically presented to the network. So that's a little bit, that doesn't meet that 4 by 100 gig. Very, doesn't meet it from a one-to-one type basis. So I mentioned the DR4, the DR4 Plus, PLR4. Then that's the parallel series modules, right? So use the MPO connector that allow that aggregation back to a single QSFP DD port. Now the next transceivers use a duplex LC. I mean, a standard LC port that we're used to seeing for transceivers out in the field. And that's the FR4. It's the first one, which is a 2 kilometer. This is from as far as a point-to-point type of connection. This is going to be a direct upgrade for the CWDM4 100 gig transceiver. So you'll be able to do a drop-in upgrade, if you will, between that CWDM4 to this FR4 type transceiver. And this is one of the more high runners in the industry right now. Then there's the LR4, which is going to be the 400 gig drop-in, if you will, at 10 kilometer. And then there's also 2 8-lane transceivers, and quite frankly, this 8-lane doesn't really matter for the most part in terms of connectors or whatnot. It does matter based upon some platforms, aren't as friendly to the 8-lane transceivers, 8 by 50 optically. So what does that mean? Why do we have these 8-lane transceivers and these 4-lane transceivers? If you have customers who have concerns with latency with 400 gig, the 8-lane transceivers, so the LR8 and ER8 are probably the right transceiver for them, because the DSP inside that transceiver is not going to be retiming those from an 8-lane on the electrical side to a 4-lane on the optical side. It's going to be more of a straight pass-through and conversion, if you will. Again, a little bit of techno babble there, but that's just why, I have customers ask me all the time, why do you have an LR8? Why do you have an 8-lane when we have an LR4, which we're used to hearing for years? And that's the technical reason why that might be more attractive. Any questions about 400 gig transceivers up to this point?
Thanks, Ray.
Now, the next transceiver I really want to introduce to you is the 400 gig ZR. There are two flavors with this right now that are available in the market. The 400 gig ZR, which is for data center interconnect. And this is a coherent module. It's standards based, so we're excited about it because the previous generation of coherent modules, so the CFP2 DCO, CFP ACOs, things like that, those were not standards based. They were fairly bespoke to the network equipment manufacturer platform. These are standards based. So this is under the OIF standards group. They're designed for single span, back-to-back applications. And 400 gig without amplification, they've got 40 kilometer reach, and with amplification, they can reach up to 120 kilometers. But they're single rate 400 gig Ethernet. Now, as we get into our open ZR Plus, these are multi-rate. They can do 100 gig, 200 gig, 300 gig, and 400 gig Ethernet. They're really for regional DCI. We're seeing customers very excited about these to integrate into their long-haul transport type networks because they offer these different speeds, and they can be amplified multiple times. So, for example, at 100 kilometers, at 400 gig, they can be amplified up to 480 kilometers. And at 100 gig, it can be amplified up to over 5,000 kilometers. So this is very attractive to carriers as they look to their options to add to their DWDM network, their IP networks, things like that. And the best part about it is the 400 gig ZR and Open ZR Plus are available today. We can ship these products today. So as we look at OEM compatibility, for the QSFP-DD, Arista, we can handle all the regular transceivers across the board. We hope to have the ZR and Open ZR Plus QDD available very soon. We have some new hardware in our lab that we're working to qualify those in. Cisco, we can provide all the QDD parts. Juniper, very strong there. Nokia, Dell, Corient, Infinera. We pick our spots there where they offer products. Then OSFP, Arista is the only real platform supporting OSFP right now. And the Open ZR Plus is the next on our list there that we'll add to this chart. And that, again, is in the lab right now. We're hoping to have results very soon on that. Any questions about the 400 gig transceivers and OEM compatibility?
Hi, Ray, Hervé speaking. Concerning the 400 gig, looking at this table, what is the status if we consider the OEM Huawei?
Yeah, Huawei is not an item we have on our roadmap right now. I think in most of the territories that we have a footprint, we're seeing Huawei is no longer used as the prevalence of them and their market share is decreasing, with the exception of Latin America. We don't have a timeline on Huawei. We don't have a
in North
timeline
America,
on
yes,
Huawei.
but you
North
know,
American
Huawei are strong in Europe and in Africa.
Okay, we'll take that under consideration, Hervé.
Okay, thanks.
Any other questions about the 400 gigs items to this point?
We can go on, Ray.
Okay, this is our roadmap for 400 gig. As I mentioned, our recent products, our SR 4.2 and our ER8 transceivers. As we look to this quarter, we'll have a 40 kilometer QSFP-DD ER4 Lite. As I mentioned, the OSFP Open ZR Plus, And we'll have another AOC, which is the low power AOC, which will use a CDR. So we're excited about that. That will reduce the power consumption of the active optical cable in half. So that we consider to be a very important item as we look forward. Another highlight to look as we look to next year is a 0 dB Open ZR Plus. Now the Open ZR Plus and ZR products have a launch optical power of right around your -9 or -9 dB. Many customers want to do an IP over DWDM application, meaning they want to use that as a alien wavelength in their ROADM architecture, and they need a much higher launch power to be able to support that application. So this 0 dB Open ZR Plus will be very important to make that happen. All right. All right, with that, I'll open up any questions. Thank you. That is any questions you may have about